Hello, geometry students. Welcome to your week 8 recording. It's hard to believe that we are headed right into the last week of February. So we will be working in the week 8 folder this week and going to change things up for your warm-up this week. So instead of doing a warm-up problem based on what we learned last week, I wanted to switch things up and have you take a moment to check your current grade. So what I want you to do is open another window, log on to geometry, and take a look at your current grade. Just want to make sure that, I know most of you do that, but in case you haven't checked your grade in a little bit, I want you to do that. And then kind of do some reflecting on why your grade is where it's at. Do you have any missing assignments? And if you do, get those in as soon as possible because that's going to help you raise your grade. Look for low scoring assignments. So to find your percentage of what you're getting on your assignments, let's say you get a 7 out of 15. Or I'm sorry, I meant to say a 7 out of 20. 17 out of 15 wouldn't make any sense. Impossible. So to determine what your percentage is, all you need to do is grab a calculator and type in 17 divided by 20. And that's going to give you, going from a fraction to a decimal, right? Doing a little algebra here. And we know to go to from a decimal to a percentage, you move your decimal 2 places to the right, so that's an 85%. So just wanted to do a quick reminder of how you figure out what percentage you're getting on your assignments. And really, I recommend that if you have less than a 70% on an assignment that you redo it. Some of you might want to redo assignments that have even higher grades, and that's okay. What I want you to do is make sure that you're learning from your mistakes. All right, so what are we doing this week? Let's see. I don't know why it says this week and next. I just meant this week. So this week, you are going to take a quiz covering the first 4 sessions that we've done on probability. And then we're going to take a look at Unit 6, Session 5, which is about bivariate data. And Unit 6, Session 6, we're going to look at different ways that we can organize and display data that we're collecting. So this week in Session 6 and 5, we're looking at ways that we can display and analyze data. So switching gears a little bit from just finding traditional probability like we've been doing to collecting data and different ways to display our data this week. So just a reminder that I always build in a catch-up day every week, and make sure that you're using that to complete any assignments that you didn't get to that week or to redo low scoring assignments. So use that catch-up day to your advantage. All right, so in Session 5, what you're going to explore is lines of best fit and correlation. So what do I mean? So what I mean is if you are collecting some data, such as this table over here to the right, where this data is about an exercise machine. Let's say it's a treadmill. And the hours per week that you're spending on the treadmill. So we collected some data about the treadmill and the hours per week that you're spending on the treadmill. So you can see all the data is in this table. And what we want to do is see if we can create a line of best fit. And from that line of best fit, what's cool about a line of best fit is that you can then use that line of best fit to predict future outcomes. So that is why we create lines of best fit. Is not the only reason. One of the reasons we create lines of best fit is to look for any trends or patterns. And then we also use it to predict future outcomes. So let's go ahead and look at an example of how we create an equation of line of best fit. And so in algebra, last year you learned how to manually find a line of best fit given some data. So given a chart with some data. And this year in geometry, we want to look more at how technology can help you find the line of best fit. So we're going to save some time and let some technology find the line of best fit for us. So what I'm going to do is show you how to find the line of best fit using a website that I will share with you in just a moment, and I will put the link up in Schoology where you can find it. But before I do that, so the number of months is going to act as our X values, and the number of hours spent per week exercising is going to act as the Y values. So again, I'm going to let a website do our calculations for us. If you have a TI 83 or 84, you'll see in the lessons this week that you can use your TI 83 calculator to do the calculations this week as well. But I wanted to show this website for those of you who might not have access to a TI 83. All right, so let me share this website with you. So here is the website that I'm using in case anybody wants to open that up in a new window. So I already entered in all the data for us to save some time. And what I'm going to do is see it's a linear regression. So I'm going to come over here and click Calculate Now. And what it does, it's pretty cool, is it not only plots the points, but it shows us the line of best fit. And remember, the line of best fit is going to get as close to as many of the points when we graph them as possible. And then it's also going to give us the equation. And I shouldn't say it's going to give you the exact equation. What it's going to do is give us the values so that we can write the equation. So remember, a linear equation is y equals mx plus b. So we need to write down the slope. So I'm going to write down the slope on a piece of paper. As I'm going to do 2 decimal places. So I'm going to do negative 0.48 as my slope. And then remember, it's y equals mx. M is the slope, mx plus b, and b is the y-intercept. So we need the y-intercept. So we're going to focus on this number here. So it's 7 point, we'll go 2 decimal places, 76. I'm going to write that down. So by the way, the over here, the plus or minus is just saying that, again, this is a line of best fit. So we can't have a perfect line that hits all of our points. So remember, it's the best estimate of the line that's closest to all of our points. So our slope might be off by this amount, and our y-intercept might be off by this amount, plus or minus. So I'm just going to write down these values here to 2 decimal places, and then I'm going to go ahead and go back to the slide we were on. So there are my values I wrote down on the piece of paper, and now I'm going to insert them into the equation for the line of best fit. So we always do y equals, for slope, I'm going to put in negative 4.8 x, and then plus my y-intercept that I copied down as 7.76. So this is my equation of line of best fit. So remember, it's going to give us, we saw when we graphed it, it was a line that sloped down. And what we can do with this equation of line of best fit is, so we looked for patterns or trends. We can see that over time, the amount, as the months go on, the amount of time that we're spending exercising per week is decreasing. So that's a trend. And then we can also predict future outcomes by using this line of best equation that we just came up with. So it says, predict how many hours Kate will exercise in the 12th month. Well, let's use this equation, and remember, x represents the number of months, and then y is going to tell us the number of exercise per week, the hours. So let's go ahead and do that. Let's find that out. So I'm going to change colors here. So we've got y equals negative 4.8 times x, the number of months. We want to find out the number of hours in the 12th month, and then plus 7.76. So let's do the math. Negative 4.8. Oops, I did that wrong. It should be 0.48, not 4.8. All right, so calculator, type in negative 0.48, multiply that times 12, and then add to that 7.76, and I get 2. I get 2. So y equals 2. So that means in the 12th month, Kate most likely is going to exercise for 2 hours. So again, just to recap what we did here is we took data from a table. We used some technology to help us come up with the equation of line of best fit. And what was cool about that website I showed you guys is that it not only showed us our slope and our y-intercept, but it also plotted the points for us and showed us the actual line of best fit drawn in based on the points. And using that equation, we could look for trends and also predict future outcomes by using our line of best fit. So you guys will get to practice that this week. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. All right, so I'm not going to cover everything that you guys are going to learn in session 6. It'd be super hard to in the short amount of time that I want to make this recording. So let's move on now to session 6, where we're looking at different ways to plot our data and to analyze our data. So one way we can analyze data is to create a double line graph so that we can compare 2 different sets of data. So here, let's take a look at what it is this graph is even all about. So what we're going to do is we're going to read all of our labeled axes to figure out what this graph is all about. So the title, it says, is Visits to 2 Music Sites on the Web. Okay, so going to 2 different music sites on the internet, and the days, the first day, the second day, the third day, the fourth day, and how many visits there were. So this is per thousands. That's what this is letting us know, is that the scale is by thousands. So there was, right here, there would be 40,000 visits on day 1 to the website Music Choice. So here's our 2 different websites. We're visiting Music Choice and Pop Parade. So we are tracking how many people visit the website Music Choice and how many people are visiting the website Pop Parade. So using all of the information on this graph to help us figure out what it is that this graph is all about. So looking here again, we can say that on day 1, 40,000 people visited Music Choice and 120,000 people visited Pop Parade, and so forth. You can see. So it's pretty cool to have a double graph because you can compare 2 different things at once. So overall, can you see which website had more visits overall? Sure, right away it's pretty quick to see that that red line is typically above the blue line, except for from days 12 to 13 here. But overall, more people are visiting Pop Parade. So what other type of things can we figure out from this graph? So on what day did Pop Parade get the least number of visits? On which day did Pop Parade, so that means we need to look at the red line that represents Pop Parade and look for the least number of visits. So that means it's going to be the point that's below all the other points, and it looks like that's occurring right here. So what day is that? Day 7. We go down and we see that that's day 7. So on day 7, Pop Parade had the least number of visits. So then, looking at the next question, it says, between what 2 days did the visits to Music Choice increase the most? So see if you can answer that one on your own first. If you want to click pause and try it on your own first. All right, so we're looking at music choice now. That's our blue line. And I want to look for the biggest increase, and that looks like it occurs from here to here. So that's our biggest increase, and that happens from day 11 to 12. Day 11 to day 12. So you guys are going to look at double line graphs in session 6 and answering questions about double line graphs. You're also going to look at circle graphs. You might have heard them as pie graphs in the past, but circle graphs. So circle graphs are another way to show data comparing parts of a whole. And in this case, what is this circle graph all about? So it says Oswego Community Chorus. So it's a certain place, their chorus, and the different breakdown of types of singers that they have in that chorus. So there's 15 people who are tenors, there's 18 people who are sopranos, there's 10 that are altos, and 5 that are basses. So we are only given the numbers. From a circle graph, if you're just given the numbers, we can actually figure out the percentages as well. And that's what this question asks about. So let's find the percentage of each type of singer. So remember, the percentage is part of a whole, right? A percentage is part of a whole. So what we need to do is figure out the total number of people in the choir. That's what we want to do. And if we want to find the whole number, the total number first. That's going to be on our denominator. So how many people are there total? I'm going to grab a calculator. Let me help calculate. 15 plus 18 plus 5 plus 10. So it looks like we've got a total of 48. So the question below asks what percentage of person are altos. So let's go and find the number of altos. We've got 10 altos, yes? So then we're just going to go from a fraction, part of a whole, to a decimal, and I'm going to round to 2 decimal places, and I get 0.21. And then to go from a decimal to a percentage, we know we just move our decimal 2 places to the right, and we get 21%. And we could figure that out, the percentage for all of the types of singers by doing this same thing. So if we wanted to find the percentage of sopranos, we would do 18 over 48 and do the same thing. Find the decimal, 38, which is 38%. And we could continue to do that. So you're going to see something similar this week where you're given a circle graph with maybe just the number of different groups, and then you need to come up with the percentages. And we know percentages are part out of the total or part out of the whole. So to find a percentage, you are going to follow that. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Then the last thing we're going to cover is misleading graphs. So first of all, what I want you to do is look at this graph and tell me, this is an unemployment rates during 2 different presidency years, during Clinton years and the Bush years, and look at the U.S. unemployment rate. So who had a higher unemployment rate? Clearly, Clinton did. But how much greater does it look like his unemployment rate is? To me, it looks like it's like 3 times. I mean, because we're looking from here to here. Looks like his unemployment rates was like 3 times higher than the Bush years. But now let me uncover a box that I covered. Now look at the unemployment rates. So here it's, and I don't know what this is, the scale's there, but it says 5.2052, and this one is 5.1852. Look at how close those numbers are. So we're missing a scale over here to know what those numbers represent. Are they by thousands? I'm not quite sure, but is it percentage? I don't know. But so that would be something we would want there. But look at how close those two numbers are. Look at how close those two numbers are. This is a misleading graph because if we didn't look at the scale and what those two bars represented, it appears like during the Clinton years, the unemployment rate was 3 times as higher. So this is an example of a misleading graph. And somebody who might be a Bush fan, or maybe a Republican, might want us to believe that the unemployment rates during the 2 different presidency years were much greater than they are. So if somebody's trying to prove a point, sometimes they'll use a misleading graph to make it seem like the differences are much greater than they are. That's an example of a misleading graph. So how do we create misleading graphs? So look at where our scale started. It didn't start at 0. It started at 5.17. If it started at 0, if the scale on our y-axis started at 0 and went up in increments of 0.5, then we would see that our graphs were very close to each other. But so one way of creating a misleading graph is to not start your scale at 0, and then it's going to make smaller differences appear to be greater than they actually are. So that's one way. And you're going to explore some other ways that people create misleading graphs this week. So that's a wrap. Let me put up the key phrase assignment for this week. So went over an array of things in this recording. We talked about line of best fit and how we can use technology to create a line of best fit, and how we can use lines of best fit to look at trends, and also to see what future occurrences would be using a line of best fit. We talked about double line graphs, and then the last thing we talked about was misleading graphs. So I told you a way to create a misleading graph. What was that way? What's a tactic that you can use to create a misleading graph, to make small differences appear to be much greater than they actually are? What is a way that we can do that? And that's it. So have a great rest of your week, and if you need any help with anything, let me know.